Whether an electrical panel needs replacement depends on several factors, including its condition and specific insurance requirements. A panel built in 1969 is over 50 years old. While age alone doesn't necessitate replacement, it is a significant factor. An electrician should thoroughly inspect the panel for signs of damage, such as corrosion or loose connections. Any significant safety concerns warrant replacement. Federal Pacific panels, often equipped with Stab-Lok breakers, pose a higher risk of electrical fires. Replacement is highly recommended if the panel has Stab-Lok breakers. Contact the insurance company to understand their specific policies on electrical panels, including requirements for age, breaker type, and other safety features. Insurance companies prioritize safety, and if they perceive a safety risk from the existing panel, they may mandate replacement. There are several potential benefits to replacing an old electrical panel. Firstly, a new panel with modern safety features reduces the risk of electrical fires and accidents. Secondly, older panels may lack the capacity to handle modern appliances and devices, so a new panel offers additional capacity for future electrical demands. Thirdly, a safe and up-to-date electrical system can provide peace of mind. Alternatives to full panel replacement may exist. 1. An electrician can inspect the panel and perform repairs or upgrades to address safety concerns, which can be more cost-effective than a full replacement. 2. If the existing panel is undersized, installing a subpanel can provide additional capacity without replacing the main panel. It is recommended to consult with a qualified electrician. They can inspect the panel and offer tailored recommendations based on its condition and the insurance company's requirements. The electrician can provide options for panel replacement or alternative solutions that meet the insurance company's requirements and ensure electrical system safety. Consider the following key aspects during the electrical panel inspection process. Firstly, look for any visible signs of physical damage, such as cracks, dents, or rust on the panel box. Secondly, check for proper labeling of all circuits to ensure clear identification of each breaker's function. Thirdly, inspect the panel's grounding system to ensure it is properly connected and functioning. Fourthly, examine the wiring connections inside the panel for tightness and signs of corrosion or overheating. Fifthly, test the operation of each breaker to verify that they trip properly under overload conditions. Sixthly, assess the overall cleanliness of the panel, as excessive dust or debris can contribute to overheating. Seventhly, document any observed issues with photographs or detailed notes for future reference. Eighthly, evaluate the panel's compliance with current electrical codes and regulations. Ninthly, determine if the panel's capacity is adequate for the home's current and future electrical needs. Tenthly, obtain a written report from the electrician summarizing their findings and recommendations. Regarding the safety features of modern electrical panels, firstly, arc fault circuit interrupters, or SIs, are designed to detect and quickly shut off power in the event of an arc fault, which can cause electrical fires. Secondly, ground fault circuit interrupters, or GFCIs, protect against electrical shock by detecting ground faults and interrupting power. Thirdly, surge protection devices can protect electronic equipment from damage caused by voltage spikes. Fourthly, tamper-resistant receptacles prevent children from inserting objects into outlets. Fifthly, circuit breakers are designed to trip and cut off power in the event of an overload or short circuit. Sixthly, proper grounding helps to minimize the risk of electrical shock. Seventhly, clear labeling of circuits makes it easier to identify and shut off power to specific areas. Eighthly, dead front panels prevent accidental contact with live electrical components. Ninthly, insulated bus bars provide an additional layer of protection against electrical shock. Tenthly, regular inspections and maintenance can help to identify and address potential safety hazards. When evaluating the capacity of the electrical panel for current and future needs, firstly, calculate the total amperage required by all appliances and devices that will be used simultaneously. Secondly, consider future additions of appliances or devices that may increase the electrical load. Thirdly, factor in the square footage of the home and the number of circuits required to meet electrical code requirements. Fourthly, consult with an electrician to determine the appropriate panel size and amperage rating for the home's needs. Fifthly, ensure that the panel has sufficient spare capacity for future expansion. Sixthly, consider the use of energy-efficient appliances and lighting to reduce the overall electrical load. Seventhly, evaluate the condition of the existing wiring and ensure that it is adequate for the increased load. Eighthly, consider installing a subpanel to distribute the load and provide additional capacity. Ninthly, obtain a professional load calculation from an electrician to determine the precise electrical requirements. Tenthly, prioritize safety and ensure that the electrical system is properly installed and maintained. Regarding the compliance of the electrical panel with current codes and regulations, firstly, the National Electrical Code, or NEC, is the standard for safe electrical installations in the United States. Secondly, local building codes may have additional requirements that must be met. Thirdly, the electrical panel must be properly grounded to prevent electrical shock. Fourthly, all wiring and connections must be made in accordance with NEC standards. Fifthly, circuit breakers must be properly sized and installed to protect against overloads and short circuits. Sixthly, arc fault circuit interrupters, or size, are required in many areas to protect against electrical fires. Seventhly, ground fault circuit interrupters, or GFCIs, are required in wet locations to protect against electrical shock. Eighthly, the electrical panel must be properly labeled to identify each circuit. Ninthly, the electrical panel must be accessible for inspection and maintenance. Tenthly, a permit may be required for electrical panel replacement or upgrades. When addressing insurance company concerns regarding electrical panel safety, firstly, provide documentation of any electrical inspections or repairs that have been performed. Secondly, obtain a written statement from a qualified electrician confirming that the electrical system is safe and up to code. Thirdly, provide proof of compliance with all applicable electrical codes and regulations. Fourthly, explain any upgrades or improvements that have been made to the electrical system. Fifthly, offer to provide access to the electrical panel for inspection by the insurance company's representative. Sixthly, request clarification from the insurance company regarding their specific concerns and requirements. Seventhly, consider obtaining a second opinion from another insurance company. Eighthly, be prepared to negotiate with the insurance company to find a solution that meets their requirements and your budget. Ninthly, explore options for increasing the insurance coverage to offset the perceived risk. Tenthly, consult with an insurance agent or attorney to understand your rights and options. To identify Federal Pacific Stab-Lok breakers, firstly, look for the Federal Pacific Electric, or FPE, name or logo on the panel of breakers. Secondly, Stab-Lok breakers have a distinctive red stripe down the center of the breaker. Thirdly, the breakers are often thinner than standard breakers. Fourthly, the breakers have a unique method of attaching to the bus bar. Fifthly, the breakers may be difficult to trip manually. Sixthly, the breakers may not trip properly under overload conditions. Seventhly, the breakers have been linked to a higher risk of electrical fires. Eighthly, the breakers may have a UL listing that is not valid. Ninthly, the breakers may be recalled or subject to a safety alert. Tenthly, consult with an electrician to confirm the identification of Federal Pacific Stab-Lok breakers. Regarding the risks associated with Federal Pacific Stab-Lok breakers, firstly, they may fail to trip under overload conditions. Secondly, they may cause electrical fires. Thirdly, they may not provide adequate protection against electrical shock. Fourthly, they may be difficult to detect and identify. Fifthly, they may be installed in older homes. Sixthly, they may be subject to a class action lawsuit. Seventhly, they may be a safety hazard. Eighthly, they may not meet current electrical codes. Ninthly, they may be a financial liability. Tenthly, they should be replaced by a qualified electrician. When determining the cost of electrical panel replacement or upgrade, firstly, obtain multiple quotes from licensed and insured electricians. Secondly, consider the size and amperage rating of the new panel. Thirdly, factor in the cost of labor and materials. Fourthly, account for any necessary permits or inspections. Fifthly, determine if any wiring upgrades are required. Sixthly, consider the cost of relocating the electrical panel if necessary. Seventhly, ask about any rebates or incentives that may be available. Eighthly, compare the cost of different panel brands and models. Ninthly, negotiate the price with the electrician. Tenthly, get a written contract outlining the scope of work and the total cost. For finding a qualified and licensed electrician, firstly, ask for referrals from friends, family, or neighbors. Secondly, check online review sites for electrician ratings and reviews. Thirdly, verify that the electrician is licensed and insured. Fourthly, ask for proof of insurance and licensing. Fifthly, check with the Better Business Bureau for any complaints against the electrician. Sixthly, interview several electricians and ask for references. Seventhly, get a written estimate from each electrician. Eighthly, compare the estimates and choose the electrician that best meets your needs. Ninthly, ensure that the electrician is experienced in electrical panel replacement or upgrades. Tenthly, verify that the electrician is familiar with local electrical codes and regulations. When preparing for an electrical panel replacement or upgrade, firstly, schedule the work with a licensed and insured electrician. Secondly, obtain any necessary permits from the local building department. Thirdly, disconnect all electronic equipment and appliances from the electrical system. Fourthly, clear the area around the electrical panel. Fifthly, ensure that the electrician has access to the electrical panel. Sixthly, be prepared for a temporary power outage. Seventhly, arrange for alternate power if needed. Eighthly, inform your neighbors of the planned power outage. Ninthly, be available to answer any questions from the electrician. Tenthly, inspect the completed work with the electrician. After electrical panel replacement or upgrade, firstly, inspect the completed work with the electrician. Secondly, verify that all circuits are properly labeled. Thirdly, test all breakers to ensure they are functioning properly. Fourthly, reconnect all electronic equipment and appliances to the electrical system. Fifthly, dispose of the old electrical panel properly. Sixthly, keep a copy of the electrician's invoice and any permits or inspection reports. Seventhly, monitor the electrical system for any problems or issues. Eighthly, schedule regular electrical inspections to ensure the system is functioning safely. Ninthly, update your home insurance policy to reflect the electrical panel replacement or upgrade. Tenthly, enjoy the peace of mind knowing that your electrical system is safe and up to code. Remember that electrical work can be dangerous, so it is important to hire a qualified and licensed electrician for any electrical panel replacement or upgrade. Consulting with multiple electricians and obtaining several quotes will help ensure you are getting the best price and service. The key is to prioritize safety and ensure that all work is done in compliance with local electrical codes and regulations.